Hello everyone, I'm Paul and today we're solving problem 3068, find the maximum sum of node values. This is a hard problem, but there's one big observation we can make here to make this easier. So keep watching for the intuition, approach, and efficient solution. This is a long description, but basically we are given an undirected tree, meaning a graph, an integer k, and an array nums. Every value in nums represents the value of a node. So for example, nums at I represents the value of the node numbered I. And we can perform an operation any amount of times. And this is the operation we can perform. We can choose any edge. Every edge has two values. And we can transform each of these two values into each value x or the value k. And our mission is to return the maximum possible sum of values that we can achieve by performing this operation any amount of times. Now there are many ways to solve this, but there's one big observation that we can make here to make this much easier. Let's say we have this graph, and now let's say we want to move from A to D. The first step is to move from A to B. So the new A in this case will be A XOR K, and the new B will be B XOR K. Now we need to move from B to C. So remember, the current B is B XOR K. So the new B will be B XOR K XOR K. And every time we have two XOR Ks, we get the same value as before, just a B. So the result for this will be B. And similarly here, up to this point, we will get C XOR K. And now we want to move from C to D. So the new C will be C XOR K XOR K, meaning this is C. And the new D will be D XOR K. And here is the main observation we need to make for this problem. Remember, we were going from A to D, and the only different values in all of these are A and D. A is now A XOR K and D is now D XOR K. What this means is we can choose any pair of nums in the entire graph. Now remember, we were given edges, we were given nums, and we were given a k value. We don't actually need these edges anymore. We can only work with the array of nums because we can choose any pair in the entire graph. So we don't need edges anymore. Now, in case you're wondering how this works exactly, let's say we have 1 in binary and a 2 in binary. And now remember that XOR returns true when we have different bits, okay? So for example, let's say we're doing 1 XOR 2. The result for this in binary is 1 and 1, and this is a 3. So the result for this is a 3. And now let's say we're doing 3 XOR 2 again. We did it here, and we are using the same 2 here. Now 3 XOR 2 is 0, 1, because these bits are equal and these are different, and 0, 1 is 1, so the result for this is 1. So the first time we did XOR 2, the result was 3, and the second time we did XOR 2, the result was 1. So we started with a 1, we did 2 XOR 2s, and we ended with a 1. Now going back to our problem, let's say we have these nums and this k. Now we know that we can work with the array of nums and k only, because we can reach any node from any other node and just transform each value in those two nodes with the value x or k. And this pattern is the same for every two values in this entire array. So from here we can take every one of these values. Let's say we take this one first, and we transform this into 1, x or 3. And remember, in binary 1 is 0, 1, 3 is 1, 1. So 1 x or 3 is 1, 0. And this is 2. So we know this is 2, and we know the current value is 1. We can do 2 minus 1 to get the difference between the new value and the current value. So in this case the difference is 1. And we will store this in another array of differences. So in this case the value in the new array for index 0 is 1. And we are doing the same for every value in nums. Here we're doing 2 XOR 3, and remember 2 in binary is 1, 0, and 3 in binary is 1, 1. So 2 XOR 3 is 0, 1, and this is 1. So now we want to get the difference between the new value 1 and the current value 2. This is minus 1. So we put a minus 1 here in the new array at the same index. And finally we have another one here, so we put in the new array another 1. And now with this we can get the result. First we'll take the sum of nums. This is 1 plus 2 plus 1, meaning 4. So sum is 4. And then we can sort this new array in descending order. So the new sorted array will be this one. Now why are we sorting this? Well, because remember, we can take any pair of nums in the original array. This array includes only the difference between each value x or k and the previous value. And if we sort this and we iterate this from left to right in steps of 2, we can get every possible pair starting from the pairs with the highest difference first. So we start here, and if 1 plus 1 is greater than 0, if this is a positive number, we can just add 2 to the result, because remember, this array is built with differences only. So we can just add 1 and 1 to the result. So the result is now 4 plus 2, this is 6. Next, we don't have any more pairs because we only have one value remaining. So we end the array here and we return this, which is the result. Time complexity for this will be big O of n log n. This is basically because we need to sort the array, and space complexity will be big O of n, basically because of this new array we need to build and sort. So now let's go with the code and hopefully you will get the idea. First, n equals length of nums, and we need to build this new array. We'll call this diff from difference. This is initially an array with 0 times n. And now for I in range n, diff at I equals nums at I XOR k minus nums at I. Now we can sort this new array, so diff.sort and reverse equals true. Now total is initially the sum of nums. We will return this, and here in between for I in range from 1 up to n in steps of 2 values. Remember, we are looking for pairs here, so pair equals difference at I plus difference at I minus 1, and if pair is greater than 0, total plus equal pair. So this is it for the code, and now let's submit this and see if it works. And as you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.